My name is Mike Steele from the University of Guelph, and I'd like to share with you today some of the recent research that we've been doing related to colostrum management as well as nutrition. Firstly, I like to say that the calf on a dairy enterprise is often forgotten. For example, the mortality and the morbidity rates are alarmingly high, and they haven't been changing over the last decade. So this is good in a way because there's a lot of opportunities for us to improve the overall health of calves. And when you look at the health of calves, there's a lot of opportunities to improve gastrointestinal health and also disorders in dairy calves in the first month of life. And a lot of this will come from colostrum management. So in our lab, we're really interested in many different feeding strategies and colostrum regimens that can overall improve not only the passive transfer of immunoglobulins, but also gastrointestinal health. So the research that we've been conducting in the first 3 years of our research related to colostrum has been comparing tube versus bottle feeding, the timing of colostrum, the heat treatment of colostrum, as well as the extended colostrum feeding, not only in the first day, but also the first week of life. So I'd like to start with tube versus bottle feeding, and this is a big question that comes from many dairy farmers of what is the best way to feed colostrum to our dairy calves. So we conducted studies where we fed a very large volume of colostrum, either through a tube or a bottle. And then we looked at how this colostrum moves through the digestive tract. We looked at passive transfer, as well as the release of hormones, so gut peptides from the intestinal tract that are associated with gut health. And what we found was that there was very little difference between the passive transfer of tube versus bottle. We also found the gastric emptying rate, or the rate of moving through this digestive tract, in particular from the abomasum to the intestine, was also not different. And this coincided with the amount of hormones that are released from the intestine were also not different. These hormones associated with actual gastrointestinal tract health. So what we can see from this particular study is that there's very little difference. I think it's more important just to get the colostrum into the calf immediately after birth. This led to another experiment where we conducted comparing the timing of colostrum feeding either at 0 hours, 6 hours, or 12 hours after birth. So many farmers think that they're feeding colostrum immediately after birth, but when they're feeding colostrum is when the first time that they see a calf. So that could be actually 6 hours or even 12 hours after birth. So in this study, we looked at passive transfer and also the establishment of gut microflora within the gut of the calf at different time points based on when that colostrum is delivered, comparing 0 hour versus 6 versus 12 hours after birth. And what we found, and obviously the passive transfer does increase when you're feeding it closer to birth. But what we also found, what was novel, was that the amount of healthy bacteria, in particular bifidobacteria as well as lactobacillus, were also higher in these calves that received colostrum immediately after birth at 0 hours. And there was even differences between 0 and 6 hours and also 0 and 12 hours. So it's very important to make sure that we have great monitoring and that we actually feed that colostrum as soon after birth in the first 6 hours to establish not only passive transfer, but also a healthy gut microflora. Another experiment that we did is we looked at the heat treatment of colostrum. So it's becoming even more common on many dairy farms to treat colostrum with pasteurization, so heating it to 60 degrees for 60 minutes prior to feeding. So why this is done is because you want to reduce the overpathogenic load or the bacteria load that's being delivered within colostrum. And what we found in this experiment is that there is very little difference with respect to passive transfer of immunoglobulins, but there was a difference in the overall gut microflora of these calves. So the calves treated with this heat-treated colostrum or fed heat-treated colostrum actually had a healthier gut microflora. So again, the amount of bifidobacteria, lactobacillus, the healthy bacteria, were actually elevated. And the amount of E. coli actually were decreased through the heat treatment of colostrum. So this is why we're recommending to definitely feed colostrum really early after life based on either a tube or a bottle, but also heat treatment of colostrum. So this would be a positive as well as a positive here with the heat treatment of colostrum. We also looked at how the biomolecule availability changes with the heat treatment of colostrum. And what we found is that there's specific bioactive molecules, in particular oligosaccharides, that are at very high concentrations within colostrum, and their availability increases after a heat treatment of colostrum. So this is important because these oligosaccharides are actually the food source for the healthy bacteria. So you want to maximize the amount of availability of the food source for this healthy bacteria. So this led us to one of the final experiments that we just finished about 6 months ago related to the extended colostrum feeding. So typically on farms, since we've been so focused on passive transfer of immunoglobulins, we're really concentrating on feeding colostrum in the first day of life. And most farms are feeding only 1 or 2 meals of colostrum prior to be converted into a milk diet here. And this typically happens at 12, maybe 24 hours of life, where there's a quick transition to a whole milk or a milk replacer. But if you characterize what's happening and you actually quantify some of the bioactive molecules within the first week of lactation, you'll notice that although immunoglobulins drop in their concentrations after the first and second milking to points where there's very little difference between whole milk, there's other bioactive molecules within this colostrum or transition milk in the first week of life that are typically being discarded on farms. So other bioactive molecules that can contribute to the health of the dairy calf, even when supplemented after the first day of life, include different fatty acids. So colostrum and also transition milk are very high in polyunsaturated fatty acids, which are very healthy for the calf, as well as peptide hormones such as insulin, IGF-1, which can have a pretty positive effect on overall gastrointestinal health and development, also setting up that calf for metabolism. And also oligosaccharides, as I discussed further, which are still very high even in the second and third day of lactation. So what we did in this experiment is that we had one treatment group that was just fed 1 meal of colostrum prior to transitioning them to a whole milk. And then we had other groups where we actually extended the amount of colostrum being fed, not only in the first day, but also the second and third day of life. And what we noted here is that passive transfer actually increased even after the first meal of life, but also what was really interesting is gastrointestinal development also increased. So the proportion of villi was increasing, the length of the villi, as well as the surface area of the intestine from the duodenum to the ileum was increasing through the supplementation of colostrum after the first day of life. So this will lead to many recommendations on farm of not just feeding colostrum during the first meal of life, but also extending that up until the 3 to 5 day mark in the first week of life. And you can do this through either feeding transition milk, which is typically difficult to manage on a farm. You could also supplement a colostrum that's liquid into milk, but you could also use a dried source of colostrum and supplement or mix that into the milk prior to feeding the calf in the first days of life. So with this research, I think it's a very exciting time to be a calf researcher, especially in the field of colostrum, just because there's a lot of knowledge gaps. But I think that we can learn a lot from some of these experiments and look at things outside of just immunoglobulins within colostrum and really focus on the other biomolecules that can have an impact on improving gut health, also setting up the calf's metabolism in hopes of developing a calf that can grow very well, be very healthy, and develop into a productive, mature animal.